Okay, good evening. My name is Nelson. I work for a company called Beyond Identity, and we are a identity security company. And today, I want to try something a little bit different. I'm going to try to run an attack live here, and I want to ask for participation from the audience. If you know what I'm doing, if you know what type of attack I'm trying to run, assuming that the Black Hat Network actually allows me to do that, I think those guys are pretty good. Can you shout it out? And if you do, I'll buy you a beer. Deal? All right. So what I have here is Entra infrastructure. This stuff is not different than anything you're typically using day to day. It's a Microsoft account that has been set up in Office 365. No particular thing. I have a server on the cloud that I'm running, and I'm actually going to restart that server right now and reconnect just to make sure we're all good to go. And the actual particulars of the attack is I'm going to generate something called a lure. It's a unique link that I'm going to send to a user myself in this case. And as a user, I'm going to click on that link and I'm going to go through an authentication process. And at the end, I want to show you this server here has actually captured pretty important pieces of data that I can use again later, okay? All right, so the link you see on the screen, I'm actually gonna generate my lure. And I've done a few of these, so I have 10 of them right now. I'm gonna grab the link and copy. Anybody tracking? Anybody know what I'm doing so far? Okay, so now I'm on that page, and once it loads, you'll notice it looks pretty much like a normal Office 365 or Azure login page. It usually takes a second, so hopefully, hey, we're not blocked. Okay, so I'm gonna grab credentials, and I have a username, type next. I have password. And on the side here, I have my Microsoft Authenticator. Again, none of this stuff has been modified. It's all kind of run-of-the-mill authentication. And I'm going to go through. I have my number matching attack, or my number matching here. Everybody who uses Microsoft will know exactly what I'm doing here. But notice what happened on my server. You see what's going on here? So my server was actually able to capture both the username, was able to capture my password, which you saw me type it, but pretend you didn't. And I was able to capture my authorization token. So if I take that, and there's a little command here I can run. I've done this a few times, so I have a few sessions. Number 56. This piece of software or data here, this is actually a session token for my Microsoft account. Now, I'm not the user anymore. I'm now role-playing as the adversary. What I'm going to do is I'm going to close Firefox, and I'm going to open a brand new session. I'm even going to clear my cookies, and I'm going to go to the real Microsoft page now. And notice, adversary again. I don't have to log in anymore. I can take that session cookie and use my little cookie editor here and import it, drop it. Oh, need to copy. Drop it in. And if I click import and I refresh my page, now I'm logged in as the user, right? Anybody recognizing what's going on here? Have you seen this kind of attack before? Say that again. So this is what's commonly known as an adversary-in-the-middle or a man-in-the-middle attack. And what you saw me using, it's a pretty common open source type of server, right? This one is called Evilginx. There's a paid version, there's a free version. I promise you, I'm not any kind of red teamer. I'm a developer, I build code for a living, and it took me about 35 minutes to set this up. The piece of code I didn't show you is called a fishlet. It's actually a little bit more complicated to actually set up that fishlet. And the fishlet I have running here is for Microsoft, as you saw me doing here. There are fishlets for anything. I have fishlets for Okta. I have fishlets for ForgeRock. They all have different settings, and the way you capture the cookies and what you look for in the traffic is different. But this stuff is not sophisticated. And kind of my question to you now, flipping back to the presentation, why does this stuff keep happening, right? We're supposed to be buying identity systems that should protect against this stuff, right? You saw me, this is not, again, not a sophisticated attack at all. And it's like, not anybody that you would think, man, these guys are super sophisticated. The scattered spider arrests were kids. This was a 14-year-old, a 19-year-old, and a 20-year-old. They're not pen testers, they're not red teamers. The fancy kids are also doing it, of course. But, I mean, you saw the attack. It took me about 20 minutes to run it, or it's gonna take me about 20 minutes to run it once I'm done. And it usually goes exactly what you saw. I can generate one of those lures. I can send it via email. I can put it on a QR code. I can SMS it for all you care. Anybody who clicks on it goes, oh, okay, that looks like my login page. Someone is asking me to do something, I'm at work, I'm gonna log in. And if I do, I'll maybe get a lollipop at the other end, whatever. But of course, that stuff is not very safe. These are all the phishing factors, or the factors that phishing kits can typically bypass on the left. Passwords, SMS, OTPs, push notifications, magic links, not safe. And what I want you to look at is on the other side, what actually remains secure when you're going against these type of attacks? Anything that is device bound. So if you have an authenticator that's on the same device, FIDO, passkeys, those types of things. But also any type of hardware-based credential, if you have a YubiKey that's using WebAuthn. And when you think about what's different, right? Why putting the authenticator on a separate device, on a phone, why does that fall for these types of attacks versus if you put it on the same device? And I would posit it's the context that changes. When you have an authenticator that's actually able to look for the browser and know that the challenge that's being relayed from that server, that page, whatever you're trying to log into, that actually comes from the URL that you expect. And that authenticator can check the validity of the credential, that credential that doesn't move, can check for maybe, hopefully, the posture of the device in real time as well. I think that's a more secure type of ecosystem. So at Beyond Identity, we built exactly that, right? This is an authenticator I'm going to show you here that lives on the same device that the users are trying to log in from. Not a phone, unless you're doing something from your phone, a Mac, Windows PC, Linux. We create something called a passkey. Passkey could be a FIDO passkey. It could be a passkey that you invoke through other processes. And we actually had to build it for Windows and Macs and Linux and all sorts of operating systems. But let me show you now in the kind of 10 minutes I have, what happens when I try the exact same attack against a Office 365 that has been protected by Beyond Identity. So keep in mind, authenticator is in the device. I'm not gonna have to pull out my phone again, so I'm even gonna close this movie recording here. And I'm going to, again, log out of the same account. And this account, when you see me type, is a slightly different domain. This domain in Office 365 has been federated for Beyond Identity. It's not using the Office 365 authentication. So I'm gonna copy that. Actually signing out of my little thing. And keep an eye on this, right? You saw me before when I attempted the previous request. I was able to capture session cookie, password, username, all of it. So now, if I connect to my little server again, I'm going to look, so generate the lure. Go to the same URL I went to before. And I'm going to clear my cookies just to make sure this is not reusing anything. Okay, so you see the traffic on the server. You see I'm still, well, that didn't work. Let me do it again. Sometimes I have to restart the server a couple times. So I'm going to go to my lure here. And again, this relies on users not realizing, right, that they're not actually going to the URL they expect. So let me try one thing. Just going to close Firefox completely. Restart my server. And again, go to my lure. Okay, I think it's going to work this time. So now, once I go through the login process, what you'll see is we're still going to capture the username because that's going before our process at all. But we're not going to capture any type of password because the process is passwordless. And we're not going to capture any session token. And then I'm going to tell you exactly how it works. So this is Beyond Identity. We've found the authenticator on the device that's local to the device. It's asking me to pick a credential. I can have multiple passkeys for different users. Maybe there's a privileged user, maybe not. I don't have to pick up my phone, again. And it's asking me to use a local biometric to unlock the key. It knows where I am. And now I'm connected. Oh, I told it not to finish it. But notice here, nothing got captured, right? And the other thing that's even more interesting, when we redirect it back from Beyond Identity, we know exactly what the URL for the SSO is. So we're not going to reuse the lure. We're going to always redirect back to the real URL. So to summarize, what we're arguing for is most MFA relies on phishable factors. SMS, DOTP, push notifications are not phishing resistant. You should be using phishing resistant authentication. And hopefully you're using it from an authenticator that relies on the same device, that is able to capture posture from that device and tell you, is this a company-owned device? Is this a BYOD device? Does it have the controls I expect for the type of authentication I'm authorizing? And finally, it should know exactly what the URL of the SSO is, so when a user gets phished, which is going to happen, 4% of best-in-class, know-before-trained employees still click on the lure, on the phishing link. If a user clicks on the phishing link, they shouldn't get phished. That's my talk. Thank you very much.